Hi everyone, I am Bihan Chakraborty and today I'll be discussing the problem number 231 from LeetCode, that is power of 2. So in this problem we have been given an integer and we have to say whether it's a power of 2 or not. So we have to check for this condition. If n equals to 2 to the power x. So and there's a follow up that can we do it without using loops or recursion. So first of all, I'll be discussing using loops and then I'll be discussing using bit manipulation without loops. So for using loops, it's very simple. Let's consider the number 6. Okay, so 6 binary representation is 110. Okay, so if we keep dividing it by 2, every time we like mod by 2, we get the last bit, least significant bit. So suppose if I mod 6 by 2, 6 by 2 equals to 0. Okay, so we get 0, that is this bit, first bit. Then let me divide 6 by 2. If I divide 6 by 2, what it becomes? It becomes 3 by 2 equals to 3. We are removing the LSB now, least significant bit. Now as you can see, 3's binary representation is 1 1. It's not 11, it's 1 1 in binary. So as you can see, we removed the 0 and we have 1 1 now. Then we can again mod by 2 to get this last one. Then we can again divide by 2 and 3 by 2 equals to 1. Then we will have just 1. So every time we divide by 2, you remove the least significant bit from the number, and by modding we can get that LSB. And now to check whether it's a power of x or not, like power of 2 or not, what we have to do is, let me show you some examples of powers of 2. So 2 is equals to 2 to the power 1, so it's 1 0 in binary. Okay, let me write it in this way. Yeah, so then 4 equals to 1 0 0, 8 equals to 1 0 0 0 0, 16 equals to 1 0 0 0 0. So as you can see, the one bit moves left and all the other bits are always 0. So this is how 2 to the power x looks like every time. So like while checking all the bits, we have to check whether there's only one present in the whole binary form. Okay, and if there's more than one ones present, then it's not 2 to the power of 2, because it can never have two ones inside a number. So doing that is very simple. We can have a counter first of all, then while we will check until n is greater than 0, because once it becomes 0, then all the bits are 0, we can't do anything then. So now while n greater than 0, first of all we will get the last bit, n mod 2 equals to 1. If it's 1, we increase counter. Now if it's not 1, we do nothing, we just skip it. Now n equals to n by 2. Now we remove the last bit. So next time we will check the second last bit, like that we will move. Now after this is done, we can check if cnt equals to 1, then we return true, else we return false. Okay, now another condition we have to check is that if n less than equals to 0. Okay, but we don't need that because then we will never enter this loop, and if we don't enter this loop, then there won't be any problem. We will directly like this condition will be false, so we will return false. Okay, so let me submit it. Okay, cool, it's working. So now for the approach without loops, let me show you some more cases. Like let me write the binary forms from 0 to like 10. Okay, so this is 0. Now 16 becomes this. Okay, so now if you observe, let me mark, this is 16. Okay, this is 8, this is 4, and this is 2. So as you can see in 2, 4, 6, 2, 4, 8 and 16, there's only one present, one bit present. Okay, so now look at the numbers before 2 to the power x. That is, this is 15, before 16 it has all ones. There's no 0 in this binary representation. Also here, this is 8 and this is 7. 7 has only ones. Here also 3 has only ones, and here also 1 has only ones. It doesn't have zeros. Ignore these zeros because these are insignificant. I have just written here. So it has only 1. So if you see this, now bit manipulation comes mainly from observation. So if I do bitwise AND of these two numbers, let me write it here. If I do bit manipulation, bitwise AND of these two numbers, what do I get? This bit, this is 0 and 1, and becomes 0, 1, 0, 0, 0, 0. So all of them becomes 0, right? In here also, if 8 and 7, okay, I just discussed 8 and 7, so let me add another one. Now this is 15 and 16. Here also same thing, this is 0 and these all are as 0 as well. So only in this case, and if you consider any other number, let me consider this number. Okay, so these two numbers, this will have 1, this will be 0, this is 1, 0, 0. Like for all the other cases, everything can be everything can be 0, but there will be at least one bit present. One bit set will be there. But for only this case, that is 2 to the power x and 2 to the power x minus 1, those two numbers bitwise and will always be 0. Okay, so we can directly check that in O of 1. So first of all, we need to handle a condition if n less than equals to 0. Then we will return false, of course. Now we will check if n and n minus 1 equals to 0. Then we return true, else return false. Okay, so this is the code. So let me explain. N is my given number and n minus 1 is its previous number. So suppose n is 8, then this n minus 1 is 7. So if I do bitwise AND of 8 and 7, then this is 8 and this is 7. So if I do my bitwise AND, answer would be 0. So if it is 0, we return true. Suppose I'm considering a different number, 6 and 7. Okay, 7 and 6. Okay, so this is 7 and 1, 1, 0. This is 6. So if I do bitwise AND, I will have 1, 1, 0. Okay, so as you can see, it's 1, 1, 0. It's 6 basically, so it's not 0. So that is why that will be false. So let me submit it as well. Cool, it's working. So this is the problem. If you have any doubts about like this approach or the previous one, please comment down below. I'll try my best to answer all of them. And if you have liked my video, please like and subscribe. Thank you.